So, Sirisha, how do you see the intersection of AI and the semi space?
So there's two parts of it. Using AI inside the industry itself is around how do you use it for predictive analysis, how do you use it for training, how do you use it for smart manufacturing. So that's one aspect of it. The other part that I see is AI needs these chips that the semiconductor industry produces. So how is it going to get enough of that volume? There's this thing that Sam Altman's looking for $7 trillion to build these factories, to build these chips. That's a very interesting question. I think it's going to be a bit of a challenge to get there because there's so many intersectionality around it. People, equipment, space. It's not just the money, right? And then how can you generate that because the capacity doesn't exist right now.
And what do you think are the biggest challenges that you see in the semi space with the advent of AI?
Like I said, it's some of it is getting the technology in. So you need the right technologies for someone to build this to scale. And I don't think everyone knows how to incorporate, right? Traditional industries, whether it's semi or others, are always trying to figure out how to leverage this technology while keeping their current base. So how do they incorporate this? I think I look at it largely from manufacturing standpoint. It could be in product development and new product introduction, like what products to decide to bring into the AI space just for AI technology, but how do you leverage AI to design these product processes and product management as well? And then in manufacturing, how to use it for manufacturing itself to get more yields, efficiency, cost. That's where the leverage is.
If someone is in the semi space, what is the salary that they can expect if they learn AI?
If I look at like manufacturing, which tends to have this huge range of this thing from high school, which are specialists working to technicians who usually have 2-year degrees to engineers, which are 4 years and higher, that seems to have the biggest spread. I can't speak so much to specialists because they are paid hourly, but usually technicians are around $50,000-$70,000 a year. Engineers is much more, and then it grows with that. And these are just starting salaries, right? There's a dearth of talent. And if you're going to look at the business and other aspects of it, they usually almost all require bachelor's degree. They don't have the spread. And so their salary starting ranges are probably at the higher end of 60s, something 70s there. And it depends on what role you get.
So Deepa, you are a leader in the cybersecurity space, working at Pepsico. So, what are your thoughts on cybersecurity and AI today?
AI kind of sprang upon the scene last year. It was the buzzword of the year, really. And a lot of industries, I mean, every industry really is exploring how to use AI in their space, to optimize things, to really kind of elevate what we are doing in that particular use case or application, right? Cybersecurity is no different. There are certain parts of cybersecurity that are so data intensive, right? Threat hunting, adversarial behaviors, authentication and authorization, especially the authentication, right, space, where companies are really wanting to elevate to things like biometric authentications, which is hugely data intensive, right? Things like that. So AI has a huge scope in those fields, right? Obviously your adversaries are also not immune to using AI against you. So there is that space, and so we will always need the good guys to be a few steps ahead of the bad guys, and so so there is that adversarial piece of it as well, right?
Awesome. Yeah. What if someone is trying, like in the cybersecurity space, but they want to learn AI? What is the thing that they would need, and how would it look like?
So I think everybody should be learning about AI. There are obviously a myriad of tools and resources. There are centers, there are coaching opportunities, there are tutoring, there are professional avenues available to get mastery in AI. But for sure, I think every cybersecurity professional this is not immune to this, and it's not just in the core security field. All the business use cases that we know are happening in AI, they have to be launched in a secure fashion. So the company has to also make sure that whatever they're doing in security has to be launched securely, so that it's a little less or a little more immune to being hacked by the adversaries. So definitely a huge scope and huge requirement for professionals to get trained in that.
Yeah, so what do you think is a salary range for someone who is like in cybersecurity, but they also have this cutting edge AI skills?
Depending on where you are you a fresh college graduate, obviously then you've got to get the industry experience under your belt. Somebody who is a cybersecurity professional, let's just say somebody with a couple years of experience, they're an analyst level position, right? But now they come in with AI, and so now they can, if they're in the core security profession, they can do things like threat hunting, malware analysis, and all kinds of behavioral analytics, what have you. You're talking easily a low six-figure income, even with just a couple years experience. But then you start getting into the expert, with people who have like 10 years of threat hunting experience, and they combine AI with that. You're talking easily, over 200K in terms of just salary, right? And that's just if you're in a salaried position. If you're out, kind of solving industry problems, the sky's the limit.
Wow. We have Malur Narayan here, and I want to ask you a question about how quantum and AI, how would it help each other? And what do you think is the future of AI with the quantum space?
If you look at quantum and AI, they are complementary and they need each other. So quantum will accelerate AI and AI will accelerate quantum. AI can scale certain things very well, but it also requires it has huge computation requirements for training the models, for generating outputs, for just crunching the numbers, and quantum is great at that. On the flip side, quantum has a lot of problems, like error corrections and qubit stability, etc. And for that, you really need a lot of AI algorithms to reinforce that and be able to solve those problems.
What have you seen are some of the technological advancements in the space of quantum and AI? Are there any advancements that you've seen so far?
The speed is of innovation is accelerating at a tremendous pace, particularly in AI. A little less so in quantum. In AI, of course, you're seeing every day, new innovations, and now you're able to basically build no-code language models. You're able to train your models in a much more efficient way without the need for GPUs. All of those restrictions are being slowly removed with more and more innovation. On the quantum side, I think some fundamental breakthroughs have happened. One is the research that happened in Japan recently around enabling the qubits to be stable even at room temperature, which is a very critical piece of making sure that, because part of the problem with quantum is you can't have qubits be stable for too long without it having errors. So that is a fundamental problem that needs to be solved.
Most of our audience here would like to know, how do you get into this field, especially quantum and AI?
You have to have a passion for physics, quantum physics, which is very different from conventional physics in the way you think about it. So you need to have a passion for it. But it's not that hard if you start delving into it. Read books. There are a lot of books, a lot of resources, a lot of blogs, white papers, research material that you can pick up.
What could someone expect, salaries in this field?
As far as salary is concerned, it's hard to say, but I think in the field of AI, you're already seeing salaries upwards of 150K starting salaries and ranging up to 250 with a couple of years of experience. I think that's only going to go up as more and more niche areas of AI, particularly around modeling, training, etc., and more core foundational AI skills are built. On the quantum side, I think because it's still such a niche field, it's more of a research area. I think you're going to see that also grow in terms of expertise and salaries into probably 100, 200K at least to start with.
Awesome. So Seth, how did you transition from a web designer to a storyteller?
I was working with clients and we were doing a lot of beautiful websites that we were getting paid a lot of money for and winning awards and so on and so forth. And when I went back to my clients and said, is this helping you? Essentially, is it getting, improving your bottom line? The answer was no, but we really love the work that you're doing. I kind of felt like I was falling down on the aspect of really doing what I wanted to do, which is why I got into business, which was to help other people. So I thought, okay, I need to learn more about marketing and come up with a better solution. And so I went down the path of marketing and copywriting and so on and so forth, and was introduced to the concept of storytelling. And then from there started to get into the science aspects of storytelling and the rest is kind of history.
Awesome. So, what is the one tip that you could give for anyone who is trying to improve on their storytelling? So, do you have just one tip?
I would say the simplest story that you can tell is to have a problem, a solution, and some sort of outcome or transformation at the end of the story. And then in between those three major points, you can fill in the details. And if you organize your story that way, it'll be easier for people to understand you when you're communicating to them, what you need or what you would like them to do.
So we have Rashmi here. So Rashmi, the first question is, how do you think quantum computing and AI are related to each other?
First of all, quantum computing itself, I know it sounds like something that's out of a sci-fi movie. But what we are really trying to do is build an atomic computer. Like our transistors are getting small enough where they are almost 20 atoms apart. But once they come even further, like close to about five atoms, I think that's where you start seeing quantum effects on your transistors that are being used in classical computers. With quantum computers, I think what we are instead of trying to avoid that from happening, we are going to actually leverage that and see how we can make the world of atoms kind of come together for us in the subatomic world. You've probably heard about the exorbitant amount of money that AI training actually is taking, especially Sam Altman from OpenAI. OpenAI has been talking about the amount of money that they are actually trying to raise just to keep the LLMs going, the model learning going. I think that it's going to come to a point where not just the silicon is going to run out of Moore's law very soon, but AI that actually is using classical computers and supercomputers and high performance compute today is going to need something that's faster than what our classical computers can do. But then there are these parallel developments that happen that when they actually come together, something fantastic builds out of it. And I think quantum and AI, they're both kind of running now parallel. At some point, I think they intersect. And when that happens, the real power of it is unleashed. And one needs the other, or the other needs the one. We don't know yet, but when I think there's something synergistic about it.
Wow, that sounds like such a powerful technology. And for all my audience here, what would you recommend if someone's trying to get into quantum and AI? And what would be the first step that they should do, and what kind of salaries can they expect?
We are looking for many people to come in and join the workforce here in this space. And quantum is actually a multidisciplinary field. There's not one field that says, "Oh, I'm a quantum engineer."
Right.
It's actually a multidisciplinary field. People who know physics, mathematics, which is pretty much everyone. Everyone goes through undergrad or high school of sciences. And you don't necessarily need to be a big mathematician, as long as you know how to model certain problems in a mathematical formula and be able to develop it algorithmically. So it's physics, mathematics, a background computer, electrical engineers, people who have a background in telecom engineering, embedded systems. All of those folks can make an attempt at coming into quantum. It's not rocket science anymore. I think a good quantum engineer is somebody who seeks out and uses his curiosity, asks good questions. And so kind of salaries that we're looking at right now, we need hundreds of thousands of people in the quantum engineering workforce. We have a handful right now, and that too, we bring them into our companies and we train them. But if we can put together a quantum engineering workforce that has a background in AI, I think you're looking at salaries anywhere in the range of about $120,000 to all the way up to $198,000. So almost about $200,000. So you are definitely in the upper echelons of the engineering workforce. Typically, a computer engineer starting out would be looking at about $80,000 or $90,000. But here you're in the six-figure salary. So it's because of the supply, right? The demand and supply. And very soon the demand's going to increase and we don't have enough supply. So this is a good space to be in.
Oh, wow. Yeah. Thank you so much, Rashmi.
You're welcome.
Yeah.
Thank you.